Hi everyone, in Algebra 3, today we're going to be going over your questions on lesson 72, starting on number 1. It says, how many distinguishable linear permutations can be made from the letters in the word calaboose? So distinguishable permutations means that we're going to use that equation n factorial divided by the number that are like factorial. So I am going to start with counting how many letters there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 total letters. And then I'm going to list my alike letters. So A, there's 2. And then O, there's 2. And that seems to be about it. So my equation is going to be 9 factorial divided by 2 factorial, 2 factorial. I'm not going to multiply the 9 factorial out by hand, but 2 factorial is 2 times 1 times 2 times 1. So really all you're doing is you're going to do 9 factorial divided by 4, which would give you 90,720. Okay. Cool. Now moving on to number 2. Oops. 1 minute of the beauties ran for the exit. One of the beauties ran for the exit, but arrived there 2 minutes late. If she ran y yards in n minutes, how fast should she have to run to have arrived at the exit on time? All right, so for this one, we have the distance is y, her time was m. And then her new distance is still going to be the same at y, but her new time is going to change because she was 2 minutes late. So we're going to do m minus 2, meaning that her rate is just distance divided by time. So when you're solving for a rate, it's just distance divided by time. You probably couldn't even have seen that problem, so hopefully you had your book open. Number 3, Clausewitz pays M men Z marks for W weeks of work. How many men can he hire for 1 week if he only has 1,000 marks? So for this one, we're going to do rate times time times workers equals jobs. We're just going to solve for rate first. So the time would be W. The workers is M. And the jobs is Z marks. So the rate is going to be Z over MW. Then it says, how many men can he hire for 1 week if he only has 1,000 marks? So for this one, we're going to go back to that equation, but we know what our Z is equal to. It's going to be Z over MW. Our time is 1 week. We're solving for workers, and he has 1,000 marks. So to solve, you just multiply by the reciprocal, which means that W is going to be equal to 1,000 MW divided by Z. And that's how many men they can hire. So rate times time times workers equals jobs. Now moving on to number 4. We have the ratio of beauties to queens at the fair was 14:1. If 2,550 women attended the fair and all were either beauties or queens, how many beauties attended the fair? So number 4, we have the ratio of beauties to queens. So B to Q is 14:1, which when you cross multiply it, you're going to get B is equal to 14Q. If 2,550 women attended the fair and all were beauties or queens, so it's going to be B plus Q equals 2,550. we're solving for the number of beauties. So I'm actually going to solve for Q in this equation and get Q is equal to 2550 minus B, and I'm going to substitute that in. So I get B equals 14 times 2550 minus B. Distribute gives me B is equal to 14 times 2550 is 35,700 minus 14B. So really we end up with 15B is equal to 35,700. And you just need to divide that by 15. And the number of beauties is going to be 2380 beauties. Now moving on to number 5. So for number 5, we have the sum of the last two digits in a 3-digit counting number is 7. So in a 3-digit counting number, for number 5, you're going to have hundreds, then tens, then units. So it says the sum of the last two digits of a 3-digit counting number is 7. So that means T plus U is 7. The sum of the first two digits is 5, so the hundreds and the tens is 5. And the middle digit is 4 times the first digit. So middle, the tens, is 4 times the hundreds. So if I just substitute that into the middle equation, I'm going to get H plus 4H equals 5. So 5H equals 5, meaning that the hundreds is going to be 1. If I plug that into the bottom equation, it's going to be T is equal to 4 times 1, so 4. And then if I plug that into the top equation, that will be 4 plus U equals 7. So U is going to be equal to 3. And they want to know what the number is. So if the hundreds digit is 1, the tens digit is 4, the units digit is 3, the number is going to be 143. Now let's look at number 6. So for number 6, it says 10 times the complement of the angle exceed 3 times the supplement of the angle by 318. What is the angle? So complement, remember, is 90 minus your angle. So I'm going to do 90 minus x, 10 times that, equals 3 times the supplement. So 3 times 180 minus x. And it exceeds it by 318, so plus 318. So just remember, complement is 90 minus x, supplement is 180 minus x. Distribute, give you 900 minus 10x equals 180 times 3, which gives us 540 minus 3x plus 318. I'm going to move the 900 to this side. So subtract it. Move the 3x to the left would give me negative 7x is equal to 540 plus 318 minus 900 would be negative 42. So that means x is going to be equal to 6 degrees. And that would be your result. So just remembering what complement and supplement are. So now that moves us to number 20. And we're going to be solving this between 0 and 2 pi. So unfortunately, we are going to have to solve this in radians instead of in degrees. So I'm going to start by moving the cosine x over. So I have sine squared x cosine x minus cosine x equals 0. I have to factor out the like term, which is cosine x. Leaves me with sine squared x minus 1 equals 0. Now we're going to set each of those equal to 0. So I have cosine x equals 0. Then I have sine squared x is equal to 1 because I moved the 1 to the other side. To take the square root of both sides, which means that this is going to give me sine x is equal to positive 1, and then sine x equals negative 1. Now, luckily, all three of those are actually going to use the unit circle. So I'm going to draw the unit circle. 1, 0, 0, 1, negative 1, 0, 0, negative 1. And cosine is equal to the x-coordinate. Sine is equal to the y-coordinate. So let's just start with x. I'm going to underline all the x-coordinates. So I'm looking for where x is equal to 0. And that would be at 90 and 270. So I'm going to write x is 90, 270. We're not done because we actually have to convert that to radians. Then I'm looking for where all the y-coordinates are 1 and negative 1. But it's actually the same. If you look, my y-coordinate 1 and negative 1, it's actually at 90 and 270. But again, we have to convert this from degrees to radians. So how many radians are in a degree? It's pi radians, 180 degrees. So using that unit multiplier, I'm going to get pi over 2. And then I'm going to get 3 pi over 2. And those are going to be your two answers for this one. So there are only two answers because the cosine x equals 0 and the sine x equals 1 and negative 1 actually give you the same exact answer. Now for number 21. Number 21 is actually kind of tricky because we can't actually solve this yet. So what I'm going to start by doing is setting sine t equal to x. So I'm going to have 21 is going to be 2x squared plus x minus 1 equals 0. I need to solve. So I'm going to do quadratic formula. X equals negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a. So x would be equal to negative 1/4 plus or minus 1 plus 8 is 9. So the square root of 9 is 3 over 4. So that means I have two equations. I'm going to have x is equal to 1/2. And then x is equal to negative 1, because negative 1 minus 3 would be negative 4 over 4. But I said that x in the beginning is equal to sine. So that's equal to sine t is equal to 1/2. And then sine t equals negative 1. For the sine t is equal to positive 1/2, what I'm going to do is I need to find out where sine is positive. So all students take calculus. Sine is positive in quadrant 1 with everything and s in quadrant 2. This is opposite over hypotenuse, so 1 over 2, 1 over 2. So it'd end up being negative root 3 and root 3. I'm going to stop there because I need to put this in radians. For this one, I have to use the unit circle, so 1, 0, 0, 1, negative 1, 0, and then 0, negative 1. I'm looking for where the y-coordinate is equal to negative 1, and that would be here at 270 degrees. Again, though, you have to convert that to radians, so 270 times pi over 180, you have to simplify that. But for this one, I'm going to use my snowflake chart. So my chart for 30 degrees is going to look like this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Starting at 0. It's the line closest to the x-axis in the correct quadrant. So this one's just going to be 1 away because it's in quadrant 1. So my first answer is going to be pi over 6. Second answer, 1, 2, 3, 4, 5, because it's in quadrant 2, will be 5 pi over 6. And my final answer would be that simplified, which is actually 3 pi over 2. So 3 answers for number 21. So that one is tricky. You did have to do quadratic formula in order to solve for that. Now what I'm going to do is we move on to number 22, which is going to be tricky because of that 2 that's attached to the theta. So it's tangent 2 theta equals root 3 over 1. We're looking for where tangent is positive. So it would be here and here because all students take calculus. Everything's positive in quadrant 1 and tangent is positive in quadrant 3. It's opposite over adjacent, so that would be root 3, 1, negative root 3, negative 1. This angle is going to be your 60-degree angle. So I'm going to draw my snowflake chart for 60 degrees. And that looks like this. 1, 2, 3, 1, 2, 3. My first answer is going to be 2 theta is equal to, in quadrant 1, it would be pi over 3. My second answer is going to be 2 theta is equal to 1, 2, 3, 4 pi over 3. Now to divide both sides by 2, I would end up multiplying both sides by 1/2, meaning that my first answer is going to be pi over 6. Then this answer is going to be 4 pi over 6. Now I'm going to end up with 2 answers for each quadrant. So normally you do 360 divided by 2. But instead of 360 divided by 2, we're going to do 2 pi divided by 2, which would actually end up being pi. So if I add pi to pi over 6, that would actually become 7 pi over 6. And if I add pi to 4 pi over 6, that's going to be 10 pi over 6. And I probably should have simplified that. So those 2 answers would end up being 2 pi over 3 and 5 pi over 3. And those would be your 4 answers after simplification. So I had to simplify that. So I don't think we've done a problem like that. So if you did not know how to do that, that's how you actually have to do it. So moving on to number 23, we are doing sine squared of negative 2 pi over 3 and cosine squared of negative 2 pi over 3. So what I'm going to do is I start by making my snowflake chart for over 3. 1, 2, 3, 1, 2, 3. Starting at 0, I would go to negative 2. This would be 1 and 2. So that means you're going to have a 60-degree triangle in quadrant 3. So negative 1, negative root 3, and 2. When I do the sine of this triangle, it's going to be opposite over hypotenuse, which would be negative root 3 over 2, and then we'd square it. Plus the cosine, which would be 1 over 2, negative 1 over 2 squared. This just becomes 3 over 4. This just becomes 1 over 4. So your answer should just be 1. Now looking at number 24, we have the cotangent cubed of 90 minus secant squared of negative 225 plus cosecant squared of 150. So I'm going to start by just drawing all of these triangles or unit circles, because the first one's going to be a unit circle. So 90 degrees would be here, and that would be 0, 1. And cotangent is the inverse of tangent, so that's going to be x over y. Negative 225 is actually going to put us in quadrant 2, and it's a 45-degree triangle. So negative 1, 1 and root 2. And secant would be the inverse of cosine, so hypotenuse over adjacent. Then 150 is actually going to be in quadrant 2 as well, with a 30-degree angle. Negative root 3, 2, and 1. Cosecant is the inverse of sine, so it's hypotenuse over opposite. So now what you're going to do is we're going to go x over y, so that would be 0 over 1, and I would cube that, minus hypotenuse over adjacent, which would be negative root 2, and I'm going to square that, plus hypotenuse over opposite, which would be 2 over 1, and I would square that. So 0 cubed is just going to be 0, minus the square root of 2 squared would be 2, plus 2 to the second, which is 4, giving me result of 2. Now looking at number 25, what we're going to be doing is we're going to find the mean, median, mode, variance, and standard deviation of the following data. So I'm going to start this paper here to not waste space. So I'm going to start with the median, and then I'll do the mode, then the mean, and the standard deviation, and then the variance. Okay, so the median is the middle number. So when I have even amounts of numbers, it's going to be the number in between 6 and 7. So that would be 6.5. But remember that your numbers have to be in from smallest to biggest if you're going to do it that way. The mode is the number that shows up the most. So in this case, it's 7. Now I'm going to use my calculator to solve for the mean. I'm going to do second 7 to clear everything, the data, out of my calculator. And I'm going to start entering each of my variables. So I just entered 2, then 3, then 6, then 7, then 7, then 8. So it says n is equal to 6, saying that I have 6 variables entered. Now I'm going to use second x squared. That tells me what the mean is. So my mean is 5.5. Then I'm going to do second divide, which is a standard deviation. So that would be 2.22. And then I'm just going to square that, and that's my variance. So 4.92 is your variance. So all of that I kind of either did in my head or I used my calculator for. Now moving on to number 26. I have to graph this first. So it looks like these are both going to be circles. The x squared and the y squared. Both of them are going to be centered at 0, -2. So 0, -2 is going to be the center. This one's going to have a radius of 3 because the square root of the right side is 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, it's going to be your first circle. The second one is going to have a radius of just 1. So go to the right one, up 1, left 1, down 1. So this one says less than the 9, which would be inside the 9. So inside the radius, so that it would be everything inside the circle. But this one's greater than the other circle. So that means it's everything outside of that circle. So if I want to know the difference, it's inside the big circle, but outside of the small circle. So less than means inside, and then greater than means outside when we're dealing with circles. Now for number 27, what we're going to do first is, I see there's a number outside my logarithm for number 27. So I'm going to put that to the exponent. So that would be log 7x squared plus log 749. On the right hand side, you should see that your base and the base of your log and the exponent are the same, so they cancel. So I just have 2. Now I have to combine these by multiplying the two numbers. So that'll be log 7 of 49x squared is equal to 2. To get rid of the log 7, I'm going to raise both sides to the power of 7. So the log 7 cancels. So I have 49x squared is equal to 49. If we divide both sides by 49, we get x squared is equal to 1. So therefore, x is equal to 1. Now it couldn't have been equal to -1 because you can't take the log of a negative. And in the original problem, there's an x by itself. You can never take the log of a negative. So that's why that would be +1. Now looking at number 28, again, we see a number outside my log. So those are going to become exponents. So for 28, I have log 8 of 16 to the 1/2 plus log 8 of x equals log 8 of x plus 1 squared. I need to combine the left side with the plus sign, so that means we multiply. And I actually know the square root of 16 is equal to 4, so that would be 4 times x is equal to log 8 of x plus 1 squared. Raise both sides to the power of 8 to get rid of the log 8. And then we get 4x is equal to x squared plus 2x plus 1. Set that equal to 0 would be 0 equals x squared minus 2x plus 1. That actually factors evenly because we have x minus 1 squared. Because two numbers that add to give you -2, and -1 and -1 gives you -2, and -1 times -1 gives you +1. So that means my answer for x is going to be equal to 1. Now for number 29, it says to factor over the set of complex numbers. In order to do that, we actually need to find the roots of the equation first before you can factor it. So that means I need to solve for the quadratic formula. So x is going to be equal to -3 plus or minus the square root. 3 squared minus 4 times a times c all over 2 times 1. So I have -3 over 2 plus or minus the square root of 9 minus 40, which would be the square root of 31i over 2. So these are my two roots right here. And your answer is just going to be x minus root times x minus root is equal to 0. So this -3 over 2 becomes +3 over 2. The positive root 31 turns to -root 31 over 2i again, the negative 3 over 2 turns to positive 3 over 2. And then negative root 31 would turn into positive root 31 over 2i. And that's your result for number 29. So solve for the roots of the equation first, and then you can just plug it into that formula. Oh, number 30, we have to determine if these are inverse functions of each other. So we actually have to compute their composites. So I'm going to start by doing f composite g of x, which would be f of g of x is 1/3 10 to the x minus 1. I'm going to plug that into my log function. And remember, when your log does not have a base, the base is assumed to be 10. So let's just plug that in there. So it's going to be 3 times 1/3 10 to the x minus 1. Oops. Sorry, that should be plus 1 before I ended the bracket, my bad. So I replaced the x with this entire thing. Now, 3 times 1/3 would just be 1. So really I have log base 10 of 10 to the x plus 1 and minus 1. And those would cancel. So really I just have log 10 to the x. And the log 10 would cancel, so I would just have x. That was very confusing because I messed up. So let's do g composite f. And that's exactly what we needed to equal was x. So I have g of my log function, which is going to be log, we assume the base is 10 of 3x plus 1. And this is going to go into the exponent. This is very confusing. So it goes into the g function. So this would be 1/3 times 10 to the power of log 10 3x plus 1 and then minus 1. So what you should see here is that the 10 and the log 10 actually canceled there. So you're really left with 1/3 times 3x plus 1 minus 1. And the 1 and the minus 1 would cancel. And then you have 1/3 times 3x, which is just x. So therefore, since this is equal to x, this is equal to x, your answer is yes, they are inverse functions. So if you didn't have all that work for number 30, you did not do your problem right. But that concludes all of your questions on lesson 72. I hope you guys all have a great day. Bye.